Let's look at a few problems from 7.2 to just help you with the vocabulary and the decisions that you have to make with hypothesis testing. So with this first one, they lay out, they give you the claim, they give you the significance level alpha, they give you the population standard deviation sigma, then they give you the sample statistics, so the sample mean, and the sample size. So the first thing we have to figure out here is our hypothesis testing. So the claim is that the mean is not equal to 6,000. So this is the claim. Now remember, when we're setting up our null hypothesis and our alternative, the null hypothesis has to have an equal sign. So either equal to, greater than or equal to, or less than or equal to. So since this is not equal to, it's going to have to be my alternative hypothesis. My null hypothesis would be that the mean mu is equal to 6,000. So that's the population mean. Okay, so looking at that, let's see, it looks like it would be E. So be careful, notice they put lots of craziness in there, but that is our null hypothesis and our alternative. We will need this again when we use StatCrunch and when we make decisions at the end. So let's see what's next in this problem. All right, so the next thing they asked me for was the test statistic. This has to do with our sample data. And so when you see that they're asking for the test statistic, in this section anyway, you are going to use ZStat. Now in 7.3 and 7.4, you're going to use tstat and proportion stat. But in 7.2, you're going to use ZStat. And we're going to use one sample with summary. The first thing you're going to do is put in all of your information that you got from the problem. So our sample mean of 6,300, our population standard deviation of 374, our sample size of 38, and then we're going to show our hypothesis. Well, our hypothesis is that the mean is equal to 6,000, that's for the null, and the alternative is not equal to 6,000. So at that point, you're going to hit compute. When you hit compute, you're going to get two things. You're going to get your test statistic. That is right here in the second to last column. And then you're also going to get your p-value, which for us on this one is very, very small. So on this question, they were only asking for the test statistic, and they want 2 decimals. So we're going to take our second to last column. That tells me that I've got 4.94 is going to be the test statistic. So just as a reminder down here, the sample data is where we're going to get our p-value and our test statistic. Now the p-value is going to be the area under the curve. The test statistic z is on the number line. And we're going to compare those to our significance level. So the alpha is area. That's why we're allowed to check the p-value versus the area. And then tied to the alpha is our critical value. That is actually the z that's on the number line that ties to the area for that significance level. All right, so just a little vocabulary. All right, let's see what it wants next. So next they ask for the critical value. So remember, that's tied to alpha. We know because of our alternative being not equal to, we know that we have a two-tail test, right? We've got a tail here, and we also have a tail here. And because we have a two-tail, we are going to have to split the significance level in half. So the significance level they gave me was 8%, right? 0.08. So I need to go ahead and cut that in half so that half will go into each tail. So now 4% will go into each tail. So now, because I want the critical values, I want what's sitting right here, the negative z naught and the positive z naught. So I'm going to use the normal calculator, And first I'm just going to check the left side. So I'm going to use a less than or equal to so that I'm getting the left. I'm going to put my area in here. Remember that alpha is the area. And that's going to give me my z right here. And so that's telling me that I have negative 1.75 on this side and positive 1.75 on this side. Now for this problem, they want you to just put it in a plus or minus box. And so we're just going to put 1.75 inside that box. And so we've got a plus or minus. And so these are the critical values. These are also our rejection areas. So the red shaded areas and the red part on the number line, those are both our rejection areas, and we're going to talk about that in a few minutes. All right, so now in order to figure out if we're going to reject or fail to reject, we're going to go ahead and compare our p-value that we found with StatCrunch, and that was really tiny. It was 0.0001. It was actually less than that, but we'll go with that, versus our alpha. Now our alpha, or significance level, was 8%, so 0.08. All right, so if we compare those two, we can see that the p-value is very tiny. It is way less than the alpha. And so since it's less than or equal to alpha, we are going to go ahead and reject H naught. Okay, so that's good. Since we're going to reject, we know that it can't be A and it can't be C, but it might be B or D. So now what we have to do is we've got to go back to our original hypothesis. And so our original hypothesis was that the mean was equal to 6,000. That was our null. Our alternative was that it was not equal to 6,000. And this was our claim, right? The claim was in the alternative. So what you're going to do is go on the bottom of your resource sheet, and we have two choices here. Either the claim is the null hypothesis or the claim is the alternative. Well, since the claim is the alternative, I'm going to get rid of this one. That one doesn't matter. I'm going to look at this second wording. So my claim is the alternative, and I rejected H naught. And so since I rejected H naught, I actually have sufficient evidence to support the claim. And so that would be D. It has to be one or the other. So if I reject the null hypothesis, then I'm able to support the claim if it's in the other hypothesis. Okay, so I rejected the first one. That meant I'm able to support the claim on the second one. The wording gets a little funny though, and so that's why you really want to use your resource sheet and make sure that you get this wording right. Okay, 1 down, 2 to go. Let's write down what we have from this problem. So we have a random sample of 32, so n is equal to 32. Looks like they didn't give me the sample mean. I'm going to have to find it. The population standard deviation is 4.1. Alpha is 0.01. And then let's set up the alternative in a minute. So what happens with this one is we have to go ahead and use summary statistics. So you're going to click on this box and you're going to use stat and summary statistics column. All the data is going to come in and you can find your mean that way. Now I recommend when you do this that you go ahead and use 3 decimal places. That way we'll be okay for round off error. Okay, so we used summary stats in order to get our mean. Okay, so let's go back to our standard deviation, or excuse me, back to our hypothesis testing. All right, so it says the claim is that the mean time it takes smokers to quit smoking permanently is 14 years. Okay, so the mean is equal to 14. This is also the claim. This is also the null hypothesis because it's an equal sign. And that means my alternative hypothesis is that the mu is not equal to 14. Okay, so we have equal to, not equal to. Looks like that would be A, because my claim is the null hypothesis. Okay, let's keep going. So next they wanted the test statistic. That means that I have to use Z-stat. Well, at least for 7.2, I have to use Z-stat. I put in all the information I knew. I found the sample mean with summary stats. They gave me the population standard deviation. They gave me the sample size. I put my hypothesis in here. I hit compute, and my test statistic is going to be right here. Right? And then my p-value is here. So my test statistic is going to be 1.54. My p-value is going to be 0.1246. So that all comes out of StatCrunch, which is really great. All right, so the first thing I need to do is compare my p-value, which was 0.1246, against my alpha, which was 0.01. My p-value is way bigger than my alpha, right? I have almost 13% for a p-value, and I only have 1% for alpha. So therefore, I am going to fail to reject H naught. Okay, so let's look above. Looks like I can get rid of C because that's reject, and I can get rid of D, but I still have A and B. So I have to go back and look at my original null hypothesis and alternative. So I had that mean was equal to 14. This was my claim. And then the alternative is that the mean is not equal to 14. So this time, my null hypothesis is my claim. So I don't need this part. I only need the top here, where the claim is the null hypothesis. I fail to reject H naught. And so therefore I have insufficient evidence to reject the claim. So it looks like B. I failed to reject H naught, the null hypothesis, and there is not sufficient evidence to reject the claim. Basically, that means that I'm going to head forward with the claim until they find data that would reject it. Remember, in stats, that's what we do. We work to reject the null hypothesis. Okay, one more. So a scientist estimates that the mean nitrogen dioxide level in a city is greater than 25 parts per billion. So the mean is greater than 25. That's my claim. Because that's a greater than sign and not an or equal to, that's going to be my alternative. My null hypothesis will be that the mean is less than or equal to 25. Okay, so that looks like B. And then I did have to use summary stats to find my sample mean. So I know that my sample size is 31, my sample mean is 26.903, population standard deviation is 8, and my alpha is 0.02, my significance level. Okay, let's head to the next one. So the first thing they asked me for was a critical value. So remember, critical value is tied to alpha. We know because our alternative hypothesis is greater than, we know that we have a right tail test because it goes in the same direction as the inequality in the alternative. We know that alpha is equal to 0.01. This is going to be my, sorry, 2. 0.02. And so that's going to be my area on the right-hand side. I have to make sure that I point to the right. We're going to do this in the normal calculator. And so what happens is I get a critical value here on the number line of 2.05. Okay, now this is tied to the rejection region. So I'm going to put the 2.05 in here as the critical value, but my rejection region is starting just past 2.05 and headed to the right. Everything on the right of 2.05 is going to be in the rejection region. Therefore, any z-scores greater than 2.05 are going to be in the rejection region, and therefore we're going to reject the null hypothesis. The next thing they ask for is the test statistic. So that means I'm going to go to ZStat. I'm going to put in everything I know over here, and I'm going to get my test statistic in the second to last column, and then my p-value on the end. So my standardized test statistic is going to be 1.32. My p-value is 0.0927. All right, let's do our analysis. Okay, so just to show you that there's two different ways to analyze whether you reject the null or fail to reject, let's do both. Let's first compare the p-value. We got that from StatCrunch versus the significance level, which was 2%. And if we compare these, we can see that the p-value is much greater than the alpha. And so we are going to, as it says here, we're going to fail to reject H naught. Okay, and so we could be done right there. We can always compare the p-value and the alpha, always. But we also could look at the rejection region, which we found on that other slide. And so what we found was that if the, that was 2.05, I think. This red area to the right of 2.05 would tell us that we would reject, right? So this direction, that's going to be the rejection region. But when we were doing this work, we found that our test statistic was 1.32. All right, well, zero's in the middle. That means that 1.32 would be right around here. And that is not in the rejection region. And so since it's not in the rejection region, we're going to go ahead and fail to reject. So these two tests are going to always give you the same result. It's just which one's easier. And really, comparing the p-value and the alpha is always easier. There's always a little room for error when we go to look at the rejection region. There's sign issues, there's tail issues, and so it's always easier to do the p-value and the alpha. Okay, so we are going to fail to reject. Let's go ahead and analyze our claim. All right, so we already decided that we're going to fail to reject. So now we have to go back and look at our initial hypothesis. We had a null hypothesis that the mean was less than or equal to 25. We had an alternative that the mean was greater than 25, and that was our claim. So since the alternative is our claim, we're going to look at that second paragraph. And then since we failed to reject the null hypothesis, then we do not have enough information or enough evidence to support the claim. So there is not enough evidence to support the scientist's claim because it's one or the other. So if we had rejected the null hypothesis, then we could support the claim that's in the alternative. But since we did not reject the null hypothesis, we cannot support the claim. Okay, so I just wanted to show you this slide again. We've got the sample data. We're going to use ZStat in StatCrunch. And ZStat's going to take the mean, the standard deviation, the sample size, the hypothesis test, and it's going to tell you the p-value, which is the area. It's also going to give you the test statistic, which is the z-value. That's on the number line. Now, the significance level is usually given to you. That's also the area, which is why we can compare the p-value and the alpha, because those are both areas. So that's our significance level. If we need a critical value, then we're going to use the normal calculator. We just have to remember that the area has to go on the right. So the alpha is the area under the curve. The critical value z is on the number line. And then I just showed you here the rejection regions. So if your alternative is a less than sign, then we are going to have a rejection region here on the left. And it's going to be, the rejection region is less than the critical value. If it's a right-tailed test, you're going to have a rejection region greater than the critical value. And then with the two-tailed test, you're going to have two. You're going to have one on each end. All right, I hope this helps with 7.2.